Now, for a non-inverting amplifier, it is also considered as negative feedback. So what will be the characteristics of negative feedback? Number one, you will definitely take the output and connect to your negative input. That's why it's called negative feedback. So, but this is a non-inverting amplifier, so it's slightly different from an inverting amplifier because both inverting and non-inverting amplifiers are negative feedback. That means both will share the same characteristic. From output, feed it back to the negative input via a feedback resistor. But then, the difference will be like this. Now, your V in is only to the non-inverting side. So that means your voltage is your V in is only connected to your non-inverting input. That's why it's called a non-inverting amplifier. So what will happen? You give it a positive input, you will get a positive output. Give it a negative input, you get a negative output. That's why it's called a non-inverting amplifier. And then, the inverting input must be earthed via an input resistor. So they will have variations in the drawing. Sometimes they draw this way or this way, but they are also non-inverting amplifiers. You just have to look at the characteristic. Number one, you will see that these two both also got feedback resistor that connects output to the negative input. From output to the negative input. Can you see that? V in is only to the non-inverting side. V in is only to the non-inverting side. The inverting input is earthed via input resistor. Inverting input is earthed via input resistor. You see that? So all of them will share the same characteristic. Okay? Now, first thing. So how would you be able to tell whether it's comparator, inverting or non-inverting? For comparator, we'll definitely have two inputs to both the inverting and non-inverting, and you won't have this feedback resistor. It will be open loop. That means no feedback one. That's comparator. In the moment you see got feedback here from output to negative input, is either inverting or non-inverting. For inverting, the input V in is only to the inverting side. For the non-inverting amplifier, the input is only to the non-inverting side. You see that? So it's actually quite easy to determine which circuit. And then to derive this equation for this, I'll show you how to derive. So you will remember I told you, because it's a non-inverting amplifier, you put in a positive input, you get a positive output, right? Agree? So then the current can flow from your positive output to zero. That means from a higher potential, which is positive, to a lower potential, which is zero. Understand that? So when it flows this way, the current here is called IF, the current here is called I in. Do you agree that IF equals to I in? Now, to find IF, you must find the PD between 2 points and divide by the resistance. But what is the PD between here? Firstly, you need to understand why this potential is VI. Now, the potential for your non-inverting input is VI. In order to prevent saturation, remember both the inputs must be almost the same. So since this is VI, so this point must also be almost VI to prevent saturation. So we'll assume this point to be almost VI. So the current here will flow from here to here. So which potential is higher, V out or VI? V out is higher because it's following from here to here. So the PD will be V out minus VI over RF to get your current IF. And then the current here, I in, will be equals to this potential minus this, because current flowing from here to here, higher, lower. So VI minus 0 over RI to get your I in. Then all you have to do is open up this, bring the VI over, factorize your VI, then bring the V out over V in to one side, bring the RF over, and you get the equation for a non-inverting amplifier. So if you want to call this what is called gain, V out over V in is a gain, or if you bring the V in over, you get your V out. So for a non-inverting amplifier, you must only use this equation, cannot use any other equation. So for inverting amplifier, remember from the last part, the inverting amplifier is negative RF over R in times your V in. So it's all different one. For comparator, it's just 10 to the power 5 for DC, otherwise you just look at the graph. Okay, so your gain is different values. Okay,